Are you struggling to efficiently allocate resources in your cloud simulation? Have you ever wondered how you can ensure optimal performance and cost efficiency in your cloud infrastructure and use a Cloudsim to simulate it? If you're a researcher diving into the cloud computing, resource provisioning is, I'm sure, one of your biggest challenge. Today, I'm going to show you how you can tackle this challenge using Cloudsim. The things which I'm going to discuss in this video is already written on my blog post on Cloudsim tutorials.online. Just simply go to Google search and type Cloudsim resource provisioning, put it in double quotes so that you get the search listing and the first article on the first search result, which is Cloudsim resource provisioning on Cloudsim tutorials.online. Once you are on the page, you can read about the different aspects at what are the different components with respect to resource provisioning, how the resource provisioning works in the simulation of Cloudsim for simulating cloud. It also discusses about the different kind of policies which are there in Cloudsim. This blog post has also discussed about one of the sample example, and it also has emphasized on the importance of the resource provisioning with respect to the cloud computing infrastructure and how you can simulate it. So this article can give you a lot of insights on this topic and you can take it as a reading resource. Now, before we get into the details of the resource provisioning on Cloudsim simulation toolkit, as you can already see on my screen, we have Eclipse workspace opened up and we have already set up the Cloudsim project into this. Let me just pull out my whiteboard and explain you how exactly the things happen in the Cloudsim simulation. Ultimately, the core task is to execute the jobs on the Cloudsim simulation to check that how it is going to behave on the real cloud computing system. We say that we have certain tasks or jobs to be executed. So these are supposed to be provided to the broker in the Cloudsim simulation. This broker is basically responsible for further allocating it to the data centers, and data centers are further going to execute these tasks through the virtual machines. So primarily the virtual machines are the core entities on which these tasks or jobs are going to be executed. Now let's understand that how is the infrastructure is going to be created whenever a Cloudsim simulation is being started. So to understand that, we should be able to visualize that how the infrastructure is being built up in the real world as well as in the simulation. So you can clearly see that whenever a Cloudsim simulation has been started, the very first instance which has been created is the data center instance. This data center will hold certain hosts. So for this particular example, I'm only going to take host 1 and host 2. Now this host will have certain specifications or certain matrices associated to it. So this is host 1 and host 2. So maybe this has a CPU capacity which is of 10,000 MIPS. It has a RAM capacity of let's say up to 8 GB. It has some bandwidth capacity of let's say 10,000 megabits per second. So this is what is the general, and you can also say that storage capacity that is going to be here is let's say 100 terabyte each. So both of these hosts are going to have the similar kind of setup. Now the further thing, because we are supposed to do a provisioning, and we always say that the data centers contain number of hosts and all those hosts are being virtualized. And when we say virtualized, so that means these hosts are eligible to have the provisioning for their virtual machine. So each host may hold certain set of virtual machines which may be of different sizes. So the size of the rectangular box is going to resemble that what is the requirement these virtual machines have. Now whatever the requirement or attributes these virtual machines comes with, they should align with these particular matrices, right? So CPU, let's say the host 1 is going to host a virtual machine of 1000 MIPS, second virtual machine of 5000 MIPS, and third virtual machine of not 5000, maybe I think we keep it a little bit short, that is 1500 MIPS, and rest of the we have close to 8500 MIPS is the requirement of my virtual machine 3. So if I have the requirement met, all my virtual machines are going to be hosted on host 1 as well as host 2, depending upon what is the configuration are we looking at. So let's say virtual machine 3 is going to be hosted over here, virtual machine 4 is going to be hosted over here, and virtual machine 5 is going to be hosted over here. So this hierarchy is just simple like that data center will have the instances of host which will have certain configuration defined in the simulation, and each host will be hosting some set of virtual machines which they again comes with their own specification. And from where these specifications are going to be provisioned or are going to be defined, this is going to be defined in any of the example file. So I hope we are clear with this particular set. So let me show you what is the example file I am talking about. So let's go back Now here in the Cloudsim example, let me show you the one of the file which is used as an example. So here we are going to take this Cloudsim example 1. So I'm going to double click on it, and it will open up the code for us. So here you can see within the main function there are different configurations which are being defined in the set. So here from line number 96 to line number 105, the virtual machine configuration are being defined, and the instance has been created so that it can be further provided to the broker. So here you can see the MIPS, as I was talking about, that there could be different virtual machine with different configurations. So here only single virtual machine is created, and this configuration in MIPS is 1000. That means 1000 instructions per second are going to be executed. The size here is 10,000, which resembles the storage requirement of the virtual machine. RAM resembles the primary memory requirement, that is 512, and then bandwidth is going to be 1000 megabits, and processor which is going to be allocated, this is basically defining the vCPU requirement. So this is only one, and VMM which is defined over here is a Zen. So it's just a nomenclature that we have, and once we create the instance of virtual machine, you can see all these information are being provided along with one of the very important thing, that is your cloudlet scheduler space shared. Now I'm going to talk about this time shared and space shared in further part of this video, but just for the instance, you just keep this thing in mind, that there is some sort of scheduler which is going to be associated with virtual machine, which is going to responsible for handling how the tasks which are allocated to the virtual machine are going to get executed during the simulation. So this is what we have for the configuration part. So let me proceed further. Now we just understood that how the virtual machines are being configured. Let's look at another important thing, because if you remember, we just spoke about that there is a data center. Data center has a certain collection of hosts, and each host is going to have its own set of virtual machine provisioned. So how it has been done? So let me take you to the top of this main function. Here in line number 85, you can see there is a data center which has been created in the simulation, and this has been created by using the create data center function, where a parameter has been passed as a string named as data center underscore 0. So if I want to go and check what is being defined inside of create data center function, you can clearly see that it has some bunch of instructions which are being followed for certain set of procedures. So here I just simply try to help you out to understand on that what exactly this whole thing is all about. So if we go with the sequence, the very first thing that you look at is a list of host, right? It has been named as a host list, and it is array list. So that means this is going to be containing the list of any host created during the simulation. Similarly, each host is required to have a processing element, which is basically CPU. So each host will have its own set of processing elements depending upon, is it a single core, dual core, quad core, octa core, whatever it is. So defined in the configuration, as per that it is going to be that. Then there is MIPS, which is basically how many instructions are executed in a second. Right, so MIPS stands for million instructions per second. Following which we have a PE list which is being created. You can see in the line number 171. Here what you see is there is an instance of PE is being created where the provisioning is simple. So this provisioner of processor to this particular list, which is going to be added to the host list in the later on process, basically allocates a processing element. So this is a single PE list. So that means this is a single core processor. Similarly, when we go further, just like virtual machine, there are different configuration attributes which are being provided over here. So host list is required to have the identification of the host based on the ID. So host ID is starting from 0. Same we have done with the virtual machine as VM ID. Then we have a RAM which is 2048, which is equivalent to 2 GB. Then storage, which is around 10 lakh MBs. Similarly, bandwidth is in M bits, right? Maybe bits we call it. So all these configurations are basically regarding the hardware that we are trying to simulate, whereas the virtual machine that we did is that is a virtual resource we are trying to create, which is going to be provisioned on the host. Now once all these attributes are being set, you can clearly see a host list is being added with a host instance. So that means this is the place where the real host is simulated, and then it has been added to the list so that it can be later on submitted to the data center. And that's how the whole thing happens. So here you can see within the host, you have a host ID, you have a RAM provisioner simple, bandwidth provisioner simple, storage is given, processing list, which is listed over here, is being mentioned in the attributes. And apart from that, the important thing, just like the virtual machine, we have a VM scheduler time shared over here. Now, this particular VM scheduler is of different type, right? So it's a time shared, space shared, and so on. Just similar to what we have seen previously, that there is a cloudlet scheduler, and that cloudlet scheduler is time shared, space shared, and so on, right? So if you really want to understand about it, you can simply go to within the Cloudsim. You can see that we have org.cloudbus.cloudsim, and with respect to the scheduler part, you can see VM scheduler.java, which is basically an abstract class. If you go and check this particular class, it's an abstract class. So that means it defines that what could be the possible set of implementation you are required to do in your custom schedulers. Similarly, VM scheduler space shared, VM scheduler time shared, VM scheduler time shared over subscription, and so on. So all these particular informations are being provided within these set of policy models. So I hope you are able to have some gist of that, okay, what these particular schedulers are and what these particular provisioners are. Now going forward, if we go further and try to understand that what this code is trying to bring onto the table. So you can see over here there are 3 string variables where the architecture, operating system, and the VMs are being allocated. And here in this particular case, if you try to really understand, this is just defining that what sort of architecture of the system would be, and this is just for the information purposes. Similarly, time zone, cost per memory, cost per storage, they are also being defined. So this is what is going to relate the pay as you use model of the cloud computing, and similarly the thing is there for the bandwidth as well. So if you want to really set up that what is the cost for executing an instruction on a CPU, and what is the cost for utilizing a RAM, what is the cost for utilizing the storage, this is where you can come and change that thing, and then later on you can print these information in the output of the simulation. Similarly, we can also have a SAN storage attached to the data center. And all these things are just only the attributes, or you can say the configurations that we are defining right now, just to simulate the data center during the simulation process is being initiated. Once all these attributes are being set, because we have to consolidate these attributes, this is being consolidated in the data center characteristics instance, where you can see all those parameters are being put forward, and then they are being passed on to the data center. So this is just a hierarchy of classes that has been created, right? So this is just for the purpose of managing the whole simulation in a better way. And here you can see when we are creating a data center, the name that we have given on the top, that is data center 0, is being defined over here. Characteristics is this instance which has been passed on. Then you can see there is a VM allocation policy simple, and then we have a storage list and so on. So the important thing over here is this allocation policy. Now let me just take you back to my whiteboard, and let me just give you an understanding on that what are the different things over here. So one is says provisioning, one is says scheduling. So these are the 2 different kind of policies that we have. So provisioning is basically mapping of virtual machine to the host. This is where you decide that which virtual machine goes on which host that is being hosted or collected within a data center. Whereas for scheduling is done on two levels. One is the host level, where it is going to manage the virtual machine. Another is going to be on the virtual machine level, where it is going to manage the task, or which is also known as cloudlets. So here, when you talk about host, it is VM scheduler. When you talk about virtual machine, it is going to be a cloudlet scheduler. So when you talk about the mapping, this is where you really allocate the hardware to a virtual resource during the simulation. Whereas when you talk about the scheduler part, if it is on the host level, it is where the virtual machines are being scheduled. So let's assume I have more than one virtual machine scheduled on a single or provisioned on a single host. In that case, is this particular set of virtual machines are going to be doing their execution in a batch processing or a time shared processing, right, or round robin process. So if you are defining it as a round robin processing, then it is going to give you the feel of that all the tasks are being executed at the same point of time. So their start time and end time is going to be same if all the tasks or jobs are of the same requirement. Whereas if you are doing it as a VM, as a space shared policy, which is also known as batch processing, in that case, the virtual machine 1 is going to be first executed, and then virtual machine 2 is going to be executed. So this is how this thing also going to happen in case of the virtual machine, where if the time shared scheduler has been used, in that case, all the tasks are been given equal time to execute, and context switching is going to be simulated alongside of that. If it is space shared, then let's say there are 10 tasks to be executed. So task 1, unless that is not finished, then task 2, then task 3, 4, 5, 6, 7, and so on. So this is what is the primary difference between provisioning and scheduler. And for both of these things, there is a different set of API which has been defined inside of Cloudsim simulation engine. So I hope this makes a clarity to you guys that how exactly this provisioning and scheduler thing is working around at the background. So once we have all these things in place, then we are good to go to submit it to the broker. So if I take you back to the main function, you can clearly see over here, first of all, in the first stage, the data center is being created, then data center broker, then VM list is being generated. Right now in this example 1, only one VM is created and only one data center is created, which contains only one single host. Then we have the cloudlet list, that is task. Again, only one task is being created and that has been added to the list, and this is further submitted to the broker. So here both the set of things are being submitted to the broker, and then the Cloudsim simulation gets started. So once the simulation gets started, that only then the whole set of configurations are going to be simulated, so that they can behave like a data center, which is a collection of hosts, and each host should behave like a real host in existing in the data center to provision the virtual machines with its resources, and then virtual machine further do a scheduling for the tasks, right? So let me execute this program for you. So once I execute the program, you can clearly see over here that we have only executed one single task, and that task is being allocated to one single virtual machine, right? So just to give you more clarity on this, let me also take another example, that is Cloudsim example 6. So here if I try to execute this example, you can clearly see that there are a certain number of tasks. If I give you a count, it's a 40 tasks which are being created, or 40 cloudlets which have been created, and then from the output you can understand that VM ID is 0 to 3. So that means 3 different virtual machines are right now provisioned on the data center, and each of these virtual machines are doing things in sequence. That means the batch processing is in place. So let me just show you, is it really a batch processing or not? So if I go to create data center and go to open declaration, and when I move towards data center instance, here you can see the allocation policy is simple. So that means the allocation that has been done is based on the provisioning part, and whereas when you look at the host based scheduler, it's a space shared scheduler. That is why the things are working in a sequence. So if we look at the number of hosts, there is only one single host we have. So this is the reason why all the virtual machines are on single host and they are done in a sequence part. Now if I give you a small tip on changing from space shared to time shared, in this instance, if I try to execute it again, just look at the sequence that is going to be here. So in this case, the sequence that you are going to see is that is going to be changed in terms of the allocation. So right now the number of virtual machines which are being allocated, because it was time shared, the over provisioning of the hosts are allowed, and this time this provisioning allows us to have more number of VMs to be created. So if it confuses you, don't worry. Once you get comfortable with first 2 or 3 examples, you will be able to understand this, that why this provisioning is done. So if you remember, I showed you in the initial part of the video where I mentioned that each host is supposed to have certain configuration defined, and based on that configuration the allocations are going to be, or provisioning of virtual machines are going to be done on that. So in this case, because we are going to have a time shared virtual machine to be taken care, so the provisioning of all the virtual machines, requested virtual machines are done. Whereas if I move it to the space shared, just to show you here the provisioning that has been given, so trying to create virtual machine on this data center 0 and so on, and then it says that all the allocations are being done. So 20 allocations are being done. Whereas when I use a space shared scheduler, and because it is supposed to have the batch processing to be done, so trying to create the virtual machines, but only first 4 virtual machines are created, rest all the allocations are failed by the MIPS. So this is what happens when you are really trying to play with time shared and space shared. So my request is just go and do an experimentation with this example 6 or example 1, 2, 3, 4, 5 up to 6, because 7, 8 and 9 is basically going to take you further for the federal cloud computing based system or delayed submission of the task. So I would not recommend you as a beginner to get started with these 3 examples. So up to from Cloudsim example 1 to Cloudsim example 6, you can take care of the things. So this is how the provisioning of your virtual machine happens to the host, and this is how the scheduler happens to your host. So rest is I'm leaving to you guys to do an experimentation. So what task you can take away from this? One is that you should try to change this VM scheduler space shared or time shared, vice versa. And similarly, you should try to change the virtual machine's cloudlet scheduler, which is provided over here. Let me just show you. In the function, there should be a function defined for that. Where is the virtual machine? Okay, so this is a create VM. Let me just open, and here you can see I can try and change this from space shared to the time shared. The only thing that you need to remember is if you are changing it to time shared, in that instance it should have the import at the top, which is cloudlet scheduler time shared or cloudlet scheduler space shared. So if you find any error, you should have these imports over here, and similarly is for your virtual machine space shared and time shared part. So this is how you can do your simulation. And that's a quick overview of resource provisioning in Cloudsim. This is just the beginning. There is so much more you can do with custom policies and advanced simulations. If you are eager to deep dive, join my course community at SuperWitsAcademy.online. There you will find more in-depth tutorials, resources, and a community of like-minded people. This will help you to master the Cloudsim simulation toolkit, and it is going to help you grow in your research career. Also, if you find any value out of this particular video, I request you to give us a thumbs up, like button, subscribe to our channel, and hit the bell icon so that you get a notification whenever we upload a new video on it. Thank you very much, and sign up today and take your cloud simulation skills to the next level. See you on the community. Bye-bye.